As we're still talking about the types of energies, we discussed about the potential energy, and today we will talk about the kinetic energy and the governing equation behind it. When you have an object stand still at a certain height, it is holding a potential energy. That energy can be calculated using the mass by gravitational acceleration by the height of that object from the surface of the earth. And for kinetic energy, if the object decides to move either through an external force that push him to get moving, or by other effects, by removing the friction, or by the influence of gravity and surface inclination, then this object is producing kinetic energy that can be calculated through a governing equation. When you have a person that is holding an arrow on his bow, when he pulls the arrow towards the string of the bow, you are storing potential energy to that arrow. When you let the arrow go, that moment the arrow will gain speed and motion in the space-time fabric. In that case, we say the arrow is moving by terms of kinetic energy. Same thing when you have a hiker standing on the edge, he's holding a rock. The rock is holding a certain potential energy. When he let the rock go, the rock will be accelerating in free falling with the influence of gravity at a certain speed v. So the force of gravity accelerates the rock downwards, increasing the speed, which means giving it kinetic energy. We need to know that kinetic energy is a scalar quantity. It doesn't have a direction. The kinetic energy is of an object is calculated using the equation E kinetic equals 1/2 mass by velocity squared. Let's take an example to define that equation in better terms. Let's assume we have a car on a highway with a mass of 1.2 by 10 to the power of 3 kilograms, traveling at a speed of 20 meters per second. It has kinetic energy equal to a loaded van of mass 4.8 by 10 to the power of 3 kilograms. What is the speed of the van? We have mass 1 equals 1.2 by 10 to the power of 3 kilograms. We have mass 2 of the van, 4.8 by 10 to the power of 3 kilograms. We have the velocity of the car, which is v1, 20 meters per second. And we know that the kinetic energy of car equals the kinetic energy of the van. Now what we need to find, we need to find the speed of the van, v2 in this case. We know that kinetic energy equals half mass by velocity squared. We will find the kinetic energy for car, which equals half mass 1 by the velocity of the car squared. And by calculation, you will find that 1/2 by the mass 1.2 by 10 to the power 3 by 20 would give you 2.4 by 10 to the power 5 joules, or kilogram meter squared over second squared. Since kinetic energy of car equals kinetic energy of van, we say kinetic energy of van equals as well 2.4 by 10 to the power 5 joules, which would be represented as well as 1/2 mass 2, which is mass of the van, by the velocity of the van squared, which we are looking for, or v2 in this case. Now we have 1/2 by, we know the mass of the van. By rearranging the equation, v van would equal the square root of 2.4 by 10 to the power of 5, which is E kinetic, over the mass of 2.4 by 10 by the mass of 4.8 by 10 to the power 3 kilograms would give you 10 meters per second. Let's take another example. We have a man on a trampoline. His mass is 75 kilograms. At the instant he touches the surface of the trampoline, he is descending with a speed of 8 meters per second. At his lowest point, the man is 0.65 meters below the trampoline's surface or rest position. So he pulled the trampoline down 0.65 meters. What is the kinetic energy of the man when he first contacts the trampoline? And the second term, if you assume that at his lowest point, all of the man's kinetic energy is transformed into elastic potential energy, what is the elastic constant of the trampoline? Take it bit by bit. Let's focus on branch 1 of the question. We have the mass 75, we have velocity, and the displacement of 0.65 meters. Find the kinetic energy EK. EK equals 1 over 2 mass by velocity squared. We have the mass and we have the velocity. You can find EK 2.4 by 10 to the power 3 joules. We already solved branch A of the problem. The little more complicated branch is branch B. We assume the elastic potential energy at 0.65 meter is this one, 2.4 by 10 to the power 3 joules. And we solve for the elastic constant. Elastic constant is, for the potential energy, is K. So what is the E potential? 1 over 2 by K x squared. We have x, and we can say, based on what is given, the man's kinetic energy is transformed into elastic potential energy. It means in this term that kinetic energy equals potential energy. Since EP equals EK, that means 2.4 by 10 to the power 3 equal 1 over 2 by K by x squared, which is 0.65 squared. Find K, rearrange the equation. 2EP over x squared would give you 2 by 2, 2.4. 2 by 2.4 by 10 to the power 3 over 0.65 meters squared. And that would give you the elastic constant for that trampoline.